Hey folks, this is John here, broadcasting from Leadville. I wanted to review some of the Hall systems that we chatted about in class. So I wanted to construct a 6-to-1 Hall system. The 6-to-1 Hall system is kind of a really common one for small team crevasse rescue. We've looked at 2-to-1s and 3-to-1s. The 2-to-1s, remember, are called the drop Cs. The 3-to-1s are called the Z-drags. We looked at those independently as simple Hall systems, but when we combine them, we get a compound Hall system. And so I'm going to show you how to build a 6-to-1, which if you break it down, it's two simple Hall systems stacked on top of each other. All right, so got a rope here with a figure 8 on a bite. This is going to be part of the drop C. This is it's going to fix it to the anchor over here. Take it to a locking carabiner. Lock it up, bring it down to the anchor. So it's called the drop C. So in real life, you might be dropping a loop to a victim who's in a crevasse or down in a gully or in a creek bed. So right now I have a 2-to-1 Hall system. This is the drop C, the 2-to-1 Hall system. If we go back to counting the mechanical advantage, we have 2 strands attached to the load. So that's a 2-to-1 Hall system. If we use the adding tensions method, going back to that kind of the basic rule, if I have 1 unit of tension on this side of the pulley, I have 1 unit of tension on that side. 1 and 1 is 2, so this pulley is getting 2 units of tension on it. So I have a 2-to-1, a pretty simple 2-to-1 Hall system built right here. I don't have a progress capture. I'll be using my micro traction for the progress capture. So here we are with the progress capture in the system, but we still are dealing with a 2-to-1. There's still 2 strands attached to the load down here. So we still have a 2-to-1 Hall system. All I've done is I've redirected the load strand with the progress capture. So simple Hall system. But our goal for this exercise was to build a 6-to-1. So I'm going to build a 3-to-1 Hall system on top of this 2-to-1 Hall system, and that's going to give us our 6-to-1. So I'll take friction hitch. In this case, I'm using that Sterling hollow block. Tie a prusik. Prusik tied here. Take a carabiner. Now this does not have to be a locking carabiner. It could also be a pulley. It could also be a tiblock if you have those kinds of materials with you. But all I'm using is a simple friction hitch tied a prusik here. And then what I do is I'm building that Z-drag. I'm building that Z-drag on top of that C. I'm building that 3-to-1 on top of the 2-to-1. And so what I'm doing is I'm redirecting that brake strand. And this time I'm going to be redirecting it through another friction hitch. So now I've built my 3-to-1 on top of my 2-to-1. And when you stack Hall systems like this, you multiply them. 3 times 2 is 6, and this gives me a 6-to-1 mechanical advantage. So this is almost identical to how Jeff Ward from the AMGA did this in the crevasse rescue system. He had a micro traction and a drop C to the victim, and then he built a Z-drag on top of that. We're going to count out the strands. We can separate the systems just like the handout on D2L goes over. We can separate the systems. So if we kind of draw a line of the friction hitch, we have 1 and 2 strands here. There's our 2-to-1. In the upper part of the system, we have 1, 2, and 3 strands. That's our 3-to-1. If we're going to do the addings tensions method for the for the 3-to-1. It gets a little bit more tricky, but I think it's worth reviewing. I have these 3 strands. If I have 1 unit of tension here, that 1 unit of tension is going to also be applied on the other side of the carabiner. So 1 unit of tension here, 1 unit of tension here. This goes back up through the pulley. If there's 1 unit of tension pulling here, 1 unit of tension is pulling here. So when I add them up, these are all 3 of these strands are pulling 1. But this is where it gets kind of interesting. If I'm pulling 1 strand over here and 1 strand over here, this friction hitch here, this is my tractor, suddenly this tractor is pulling 2. 1 and 1 is 2, and then this strand is 1. We've already calculated that. So for every 1 unit of tension that I'm pulling on this Hall strand, there's going to be 3 units of tension going right here. Thinking back to adding the tensions, right? If I have 3 units of tension on this side of the pulley, 3 units of tension are going to be on this side of the pulley. 3 and 3 is 6. So for every 1 that I pull, there are going to be 6 units of tension on the victim down in here. You can also think about it, for every 6 feet of rope that I pull up, that victim is going to be coming up 1. Every 6 feet that I'm pulling up, that victim's going to be coming up 1 feet. Reset my tractor, reset that prusik, and keep pulling. So that's a couple different ways to go over building 6-to-1s as well as adding them up. We just build a Z drag on top of that C.